Okay, today we're going to start lesson 8.2. Our goal of the lesson is to find the measures of the interior and exterior angles of polygons. So we're still continuing on with the polygons, and so we're going to talk about inside and outside angles of those polygons. For interior angles, we can see by theorem 8.1 that the sum of the measures of the interior angles of a convex polygon with n sides, that could be any number of sides, is always going to be the formula m minus 2 times 180. Now, one of the simplest ways that I try to help you all remember that is by looking at a rectangle first. So if I have a rectangle here, and I want to know what is the sum, or what is the measures of the interior angles of that polygon with four sides. Well, if I draw a diagonal in that rectangle, we need to think about how many triangles are formed by that diagonal inside the rectangle. Well, that would be 2. And we all know that a triangle's angles always add to 180 degrees. So, how many sides do we have for the rectangle? That's 4 sides. And how many triangles are formed? Well, that's 2 triangles formed. So, the formula for finding the sum of the interior angles is always going to be n minus 2, because that's how many triangles are formed by the diagonals. And then we can just multiply that by 180 degrees, because we know each triangle will have 180 degrees. Theorem 8.2 says polygon exterior angle theorem. This theorem says that all the angles outside of a polygon, of a convex polygon, one angle at each vertex is 360 degrees every time. It doesn't matter how many sides the polygon has, the sum will always be equal to 360 degrees. So the example 1 says we want to use the polygon interior angles theorem. We want to find the sum of the measures of the interior angles of the polygon. So we know a polygon has, this polygon has 6 sides, 1, 2, 3, 4, 5, 6. And so the formula says that we're going to do n minus 2, the number of sides, minus 2, times 180. Well, again, the reason why is if I take one of these vertices and I draw all the triangles inside this polygon, the number of triangles that are formed is 1, 2, 3, 4 triangles. So if the number of sides is 6, if it's a hexagon, then we would do 6 minus 2 to get our 4. So that would be 4 times 180, and that would equal 720 degrees inside this hexagon. That's for any convex hexagon. The exercises take a moment to draw the number of triangles in each one of these, 1, 2, and 3, and decide what the sum of the interior angles would be in each polygon. Or you can go straight to using n minus 2 times 180. Okay, so for number 1, it is a quadrilateral. It's 4-sided. We've already had our quadrilateral unit. We know without doing this formula that the sum should be 360 degrees. But just to reiterate the formula, we can just plug in our numbers into the n minus 2 times 180. And so the number of sides is 4. 4 minus 2. 4 minus 2 is 2. 2 times 180 would be 360 degrees. And that would be the sum. Number 2, we have a pentagon. So we would have one triangle here. Oops. And 2, 3. There's 3 triangles, so we would do 3 times 180. Or in this case, a pentagon is 5 sides. 5 minus 2 times 180, 3 times 180, and 3 times 180 would be 540 degrees. The last one, the octagon. If it is an 8-sided figure, it should have 6 triangles that can be drawn from the same vertex to all the other vertices. Okay, so that should give me 6 triangles, and it does. And so now we do octagon is 8 sides, 8 minus 2 times 180. And that gives me 6 times 180. And 6 times 180 is 1,080 degrees. Example 2 says find the measure of an interior angle. So we want to find this angle A. And we need to decide, well, what do all the angles inside of this figure add up to? And this is a 5-sided figure, so we would substitute 5 in for the n spot, the number of sides. 5 minus 2 times 180, 3 times 180 would give me 540 degrees. So I know all the angles inside of this would equal 540 degrees. So now I'll take the 90 degrees, 135, 83, 96, plus the missing angle we're trying to find and set it equal to 540 degrees. The sum of these 4 angles give me 404, and if I solve for the measure of angle A, I'm going to subtract 404 from each side to get 136. So for the exercises, we need to first decide what is the sum of the interior angles of 4, 5, and 6. So take this time to try to work through 4, 5, and 6 on your own. Alright, so we're trying to find measure of angle A. I'm going to circle the angle in all of these. And I want to find the sum of all the angles inside this quadrilateral. We know that should be 360 degrees. So we would say 74 plus 115 plus 102 plus angle A equals 360 degrees. And so we would want to combine all those values. So 74 plus 115 plus 102. That gives me 291 plus angle A. And last step would be to subtract by that 291 to solve for A. And when we do that, we get angle A should be the acute angle 69 degrees. Alright, number 5. How many sides do we have? 1, 2, 3, 4, 5, 6 sides. So to figure out how many, what's the sum of the interior angles, we would do 6 minus 2 times 180. And that gives us 720 degrees. So this time I know that all the angles inside of this hexagon should add up to 720 degrees. So I'm going to start with angle, I can start with angle A plus angle B. Angle C is a right angle, 138, 128, plus 120 should equal 720 degrees. Now we'll combine anything on the left, which we can combine all the angles, 160 plus 90 plus 138, 128, 120. That gives me angle A plus 636 degrees. Now I'll subtract each side by 636. So angle A equals 80 184 degrees. And lastly, number 6. I have to decide how many sides we have. You can also count the number of angles to figure out um, what we'll substitute in for ends. This has one side, 2, 3, 4, 5, 6, 7 sides. So 7 minus 2 times 180 will get me the sum of the interior angles. That should be 900 degrees. So I'll add up all the sides and angle A. 100 times 6. I know if I'm running out of room, you all are too, because the note-taking guides are shorter brooms, but we will go on. And this should all add to 900. I'm going to add all those angles together and then subtract it from 900. And so I'm getting angle A plus 167 degrees equals 900. We'll subtract 167 from each side and get the angle A should be 167 degrees, an obtuse angle, and that is almost close to a line. The measure of a line, 180, you can see that's barely just a little angle there for angle A. So that makes sense. Lastly, we want to talk about the exterior angles of a polygon. And so the exterior angles all the way around the figure will always be 360 degrees, a complete revolution. So when we add up all these exterior angles, they should always add up to 360. So we set up the equation. This time we want to find the value of x. Well, there's two x's in this picture, one right here and here. And so that will also go into our algebra calculation. So we need to combine like terms. We get 260. Combine the x's. X plus x is 2x. And we'll subtract 260 from each side to get 100. And the last step, we'll divide by 2 to get 50. So x equals 50. So each one of these angles would be 50 degrees. And afterwards, all these angles on the outside should add to 360 if you did the correct calculation. So take this moment to work through 7, 8, and 9, knowing that all the exterior angles add to 360 degrees, no matter how many sides we start with. Okay, for number 7, again, all the way around, 360. So I can say x plus 80 plus 110 plus 100 equals 360. Combine like terms, 110, 80, and another 100 degrees will give me 290 degrees. Subtract 290 from each side, and we get a value of 70 degrees for x. Number 8, again, it doesn't matter how many sides the polygon has. We know that all the exterior angles add to 360. This time we do have two x's, so make sure that you notice that. So I'll say x plus 70 plus x plus 83 plus 47 equals 360 degrees. Combine like terms. So x plus x gives me 2x. 70 plus 83 plus 47 will give me 200 degrees total. And then to solve for x, we need to first get this constant on the right side. These cancel. 360 minus 200 will give me 160. And then we can divide by 2. X equals 80. This one. So both of these will be 80. And the last one, number 9, is a right triangle. I have this exterior angle and this one, but I do not have the value of this one. But we know that since this is a linear pair, they should add 180. So if this is 90, 90 plus what equals 180? Well, that's going to be 90 as well. So we've got to remember that first. So now we can go straight to solving for x. 90 plus the other angle, 8x, plus 6x plus 4 equals 360. Combine any like terms that you see. 90 plus the positive 4, 8x plus 6x, give me 14x. And so now I want to subtract 94 from 360. So I end up with 14x equals 266. And divide that 266 by 14 to solve for x. So x equals 19. And that is the conclusion of 8.2.